Hello everyone and welcome to Amazon Redshift Ultimate course. In this video we're going to go over an overview of what we're going to be learning throughout the course. So in section 2 we're going to create a AWS account. In section 3 we're going to talk about Amazon Redshift, so we'll cover dashboard, cluster, reserved nodes, snapshots, queries, and loads. In section 4 we're going to talk about the query editor, so we'll cover editor, query history, save queries, and scheduled queries. In section 5, we'll talk about data shares, so in my account from other accounts, okay? In section 6, we're going to talk about configuration, so workload management, subnet groups, Hsm, and managed tags. In section 7, we'll conclude the course with a conclusion and go over a summary of what we learned throughout the course. So with that in mind, thanks for watching. I'll see you inside the course. All right, let's create an AWS account. Okay, so let's go over to create an AWS account. And what it's going to ask for is an email address, a password, to confirm the password, and then an AWS account name. Now, I'm going to give you a full disclosure here. I've already created an account, so I'm not going to go through all the steps, but I will walk you through what you need to do, okay? So from email address, I'm just going to type in one of my random email addresses. I will do a password, I will do another password, and then we'll just do sample. Okay, I'll continue. So they need to verify that I'm a real person. So we're going to do, for mine it's F66M6S. I'm going to continue. Okay, then they're going to ask for contact information. How to use your plan, business or personal. Who should we contact about this account? So put your full name, your phone number, your address, city, state, postcode, okay, and then continue on. Okay, so I'm going to pause the video, I'll put all that information in, then I'm going to continue to the next step. Okay? All right, welcome back. So with this, I'm using my Finder here as kind of a way to censor my sensitive information. So what you're going to do is you're going to put in your credit card information, expiration date, the year, and then the card holder's name. Down here, it's going to show your address, okay? And then right here, you're going to verify and continue to this is step 3 of 5. So then you would continue on to the next step and then follow and set up the information that they need, so on and so forth. Okay, so that's how you set up an account. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about the Amazon Redshift dashboard. So how do we do that? Why would we use the Amazon dashboard, right? The Redshift dashboard, what would be the purpose of it? And what are the options available to you when using the Amazon dashboard? Visualize your Redshift data at scale with Amazon QuickSight, now with new capacity-based pricing for large-scale business intelligent deployment and embedded analytics in applications. You can click here to learn more. Okay, so we're not going to do that, but I just wanted to read that since it popped up. So here's the deal. Amazon Redshift dashboard, resources overview, so you can see the total amount of nodes, on-demand nodes, reserved nodes available, automated snapshots, manual snapshots, cluster overview, so you can create a cluster here, data shares, we have cluster metrics, so number of queries, database connections, disk space used, CPU utilization, okay? Then you have query overview, so query throughput, average queue length, runtime, and wait time, okay? So this is your dashboard for all of your information with Amazon Redshift, okay? So thanks for watching, and I will see you in the next video. All right, welcome back. So in this video, we're going to talk about clusters. So let's click on clusters, and you can see here that working with clusters, you can do a couple different things. Okay, you have connect to Redshift clusters, okay, and you have query data using Redshift Query Editor, work with your client tools. You can connect to Amazon Redshift from your client tools, such as SQL, clients, business intelligent BI, tools, and extract, transform, load, ETL, tools using the Jdbc or Odbc drivers. Choose your Jdbc or Odbc driver. Use Jdbc or Odbc drivers to connect to Amazon Redshift from your clients tools such as SQL clients, BI tools, ETL tools. We recommend using the new Amazon Redshift specific drivers for better performance and scalability. Okay, so you can work with that here. Then you have clusters down here, okay? And you can also do it from other accounts. So clusters and other accounts to which you have been granted access, create endpoints to access these clusters. So you can work with that here in my account and from other accounts as well. All right, so thanks for watching. I will see you in the next video. All right, welcome back. So we can talk about reserved nodes, purchase compute nodes at a reserved node rates. Okay, so we can learn more here. Let's right click and open in the new tab. And let's go to purchasing Amazon Redshift reserved nodes. Okay, so you can see kind of what the different options are here. There's no price point that I see anyway. Yeah, there's no pricing. Okay, so let's go back. So you have reserved nodes used, reserved nodes available. You can purchase reserved nodes, as I stumble through saying it. No upfront cost. You can pay $146 a month. Effective hourly is 20 cents per hour. Partial upfront $750, $54 monthly, or all upfront $1,300, $1,380, and basically a 15 cent per month, per hour rate, okay? Now, when you do the nodes, let's say you need 2 nodes, okay? Your rate is going to be let's do 10 nodes. Okay. Now you can sign up for 3 years, $2,465, not even a cent per minute because it's 0.094. Partial upfront, you can do $1,325, and the monthly rate is $36.50. It's 10 cents an hour. Okay, there's no upfront for the 3-year deal, so you can lock in this rate for 3 years. That's not a bad deal. And then you can look through here and see what kind of storage you need. So if you needed 2 terabytes, it's more money, $5,605 for all upfront. Okay, if for a year, it's $4,295. So you're just paying for what you need. Okay, so that's the benefit of doing that. So let's hit cancel. That's how you purchase reserved nodes. So thanks for watching. I will see you in the next video. All right, let's talk about snapshots. So you can set up snapshot schedule and also snapshots. Sorry. So let's create a snapshot. Take a look at this, what this does. So cluster identifier, you can choose a cluster, snapshot identifier, and then snapshot retention. Okay, so 1 day, 7 days, custom value. The retention period must be 1 to 3,653 days. Okay, so how long is it going to be around? Okay, so the snapshot is basically made for, there you go. So thanks for watching. I'll see you in the next video. All right, welcome back. So we got queries and loads. Okay, so we don't have any queries to display, but when you do have a query, this is where it would show up. So the start time, the query, the status, the duration, the SQL, the PID, and the transaction ID. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So we're going to talk about query editor. Okay, so the query editor, you can connect to a database to run queries and view results. Okay, we can look at, you can select the database, select the schema, find tables here, connect the database over there, and also here as well. Okay, so thanks for watching. I will see you in the next video. All right, welcome back. So we're going to talk about query history. So you have start time, status, duration, SQL. All right, thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about save SQL queries. Okay, so You have query name, you have description, SQL. So we can save the query, we can look at actions, open a new query tab, download SQL, and then schedule query. All right? So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about scheduled queries. So there are none scheduled right now, so there's nothing to display. But once you schedule them, the schedule name would be here, the cluster would be here, the database would be here, Amazon SNS topic would be there, and then the state would be here. So very important stuff to understand and see and visualize. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about data shares. So control data share access from other accounts. Okay, so and we're going to talk about that in the next video, but we'll also talk about this. So associate data shares with your AWS account or namespace. For data shares from other accounts, associate the data shares with AWS account or a specific namespace in your account. Consumers can work with data shares from the data share page after you accept the data shares. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk from other accounts. So control data share access from other accounts. So you have for data shares created in your account, choose AWS accounts to authorize access to or remove authorization from the data shares. Authorized AWS accounts for notified to accept the data shares. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about workload management, okay? So workload management, you got workload management, which is WLM, optimizes query performance by allocating cluster resources to query queues. You can specify automatic WLM with query priorities to let Amazon Redshift manage concurrency and memory allocation, or you can create a custom configuration. So you have parameter groups, you have automatic WLM with query priorities. Okay, so those are the two things that you're working with. So you have parameter groups contain a WLM configuration and a set of cluster parameters. When you create or modify a cluster, you associate a parameter group with the cluster by modifying a parameter group. You can change the configuration of all clusters that use the parameter group. Automatic WLM with query priorities. Automatic workload management manages query concurrency and memory allocation. Automatic WLM determines the amount of resources that queries need. It adjusts the number of parallel running queries based on the workload. To indicate the importance of workload, set query priorities. Higher priority queries get preferential treatment. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about subnet groups. So when you have a subnet group, you'll have name, status, VPC ID, description, and tags. We can create a cluster subnet group here, and you would enter in the information here, and then create it there. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about Hsm Connections. Okay, so you have connections, certificates, and frequently asked questions. So we can create an Hsm connection here. Okay, so you have the Hsm connection name, description, details. So Hsm IP address, partition password, partition name, confirm the Hsm partition password. So these are together. Paste the Hsm public server certificate here. You may need to obtain the certificate from your IT administrator, and then tags here. And then you can connect to Hsm. Okay? So with that, thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about how to manage tags. So find resources to tag. You can search for resources that you want to tag, then add, remove, or modify tags for resources in your search results so that you can put everything where you need to have it. Okay? So thanks for watching. I'll see you in the next video. Congratulations on finishing the Amazon Redshift course. In this video, we're going to go over a summary of what we learned throughout the course. So first, in section 2, we talked about how to set up an account In section 3, we talked about Amazon Redshift, so we covered dashboard, clusters, reserved nodes, snapshots, queries, and loads. In section 4, we talked about the query editor. In section 5, we talked about data shares. In section 6, we talked about configurations. So I want to thank you so much for watching the Amazon Redshift Ultimate course. If you have any questions or concerns about the content, please let me know. I'll be happy to help you in any way that I can. Until next time, thanks for watching and take care. Hello everyone and welcome to Amazon Redshift. So in this video, we're going to go over course overview and what we're going to be learning throughout the course. So in section 2, we're going to talk about Amazon Redshift, what is Amazon Redshift, and management overview. In section 3, we're going to talk about managing clusters. So we'll go over an overview, talk about usage limits, console, CLI and API, and AWS SDK for Java. In section 4, we're going to talk about querying a database. So we'll talk about the overview, query editor, Sql Client Tools, configuring connections in Amazon Redshift, security options, tools and code, troubleshooting, and data API. In section 5, we'll conclude the course with a conclusion and go over a summary of what we learned throughout the course. So with that in mind, thanks for watching. I'll see you inside the course. All right, welcome to section 2 where we're going to talk about Amazon Redshift. So in this video, we're going to go over a brief overview of what we're going to be learning throughout this section. So first, we're going to talk about what is Amazon Redshift. So we're going to be going through their documentation here and talking about what is Amazon Redshift, which I'll be clicking there. And then we're going to be talking about Amazon Redshift Management Overview, where it talks about the following here: cluster management, cluster access and security, monitoring clusters, and then databases. So we're going to cover all this information in the upcoming videos. So I'm looking forward to talking to you about this and teaching you all about everything you need to know about Amazon Redshift. So with that in mind, thank you so much for watching, and I'll see you in the next video. All right, welcome to section 2 where we're going to talk about Amazon Redshift. So what is Amazon Redshift? Okay, what is the use of Amazon Redshift? So Amazon Redshift makes it easy to add nodes to your data warehouse and enables you to maintain fast query performance as your data warehouse grows. Redshift Spectrum enables you to run queries against exabytes of data in Amazon S3. Sorry, I can't talk. So for Amazon Redshift, the Wikipedia definition of it is, Amazon Redshift is a data warehouse product which forms part of the larger cloud computing platform, Amazon Web Services. The name means to shift away from Oracle, red being an allusion to Oracle, whose corporate color is red and is informally referred to as Big Red. Okay, so that's what Amazon Redshift is. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about the Amazon Redshift Management Overview. So Amazon Redshift service manages all of the work of setting up, operating, and scaling a data warehouse. These tasks include provisioning capacity, monitoring and backing up the cluster, and applying patches and upgrades to the Amazon Redshift engine. So cluster management, creating and managing clusters, reserving compute nodes, okay? Creating cluster snapshots, cluster access and security, AWS accounts and IAM credentials, security groups, encryptions, Ssl connections, monitoring clusters, database audit, logging, events and notifications, performance, databases, and that is all of the things that you can manage with the cluster management with Amazon Redshift. So you can see here you have cluster management, cluster access and security, monitoring, clusters, and databases. And so that is kind of the overview of what you can do with management. So thanks for watching. I'll see you in the next video. All right, welcome to section 3 where we're going to talk about clusters. So in this video, we're going to go over an overview of what we're going to be talking about in this section. So we're going to be talking about the usage limits, okay, right here. We're going to be talking about the managing clusters using the console. We're going to talk about Ssl and API, and then managing clusters using the AWS SDK for Java. Okay. We're also going to look at those right there. Okay, so thanks for watching. I'll see you in the next video. Welcome to section 3, where we're going to talk about clusters. So in this video, we're going to go over an overview of what we're going to be talking about in this section. So the first thing we're going to talk about is we're going to cover the usage limits, the managing clusters using the console, managing clusters using the Amazon Redshift, Ssl and API, and then we're going to talk about managing clusters using the AWS SDK for Java. All right. The other thing we're going to do is we're going to actually talk about managing clusters overview. So we're going to talk about that right now. So in this documentation, they're going to cover resizing clusters, pausing and resuming clusters, renaming clusters, and shutting down and deleting clusters. So here we go. So after your cluster is created, there are several operations you can perform on it. The operations include resizing, pausing, resuming, renaming, and deleting. Okay, so as your data warehouse capacity and performance needs change or grow, you can resize your cluster to make the best use of the computing and storage options that Amazon Redshift provides. You can use Elastic Resize to scale your cluster by changing the node type and the number of nodes. Or if your new node configuration is not available through Elastic Resize, you can use Classic Resize. To resize your cluster, use one of the following approaches. Elastic Resize, to change the node type, number of nodes, or both. If you only change the number of nodes, then queries are temporarily paused and connections are held open if possible. During the resize operation, the cluster is read-only. Typically, Elastic Resize takes 10 to 15 minutes. We recommend using Elastic Resize when possible. Then we have Classic Resize. So use Classic Resize to change the node type, number of nodes, or both. Choose this option when you are resizing to configuration that isn't available through Elastic Resize. An example is to or from a single node cluster. During the resize operation, the cluster is read-only. Typically, Classic Resize takes 2 hours to 2 days or longer, depending on your data size. And then snapshot and restore with Classic Resize. To keep your cluster available during a Classic Resize, you can first make a copy of an existing cluster, then resize the new cluster. Okay? Now let's talk about pausing and resuming clusters. If you have a cluster that only needs to be available at a specific time, you can pause the cluster and later resume it. When the cluster is paused on demand, billing is suspended. Only the cluster storage incurs charges. Okay? For more information, you can see the Amazon Redshift pricing page. When you pause a cluster, Amazon Redshift creates a snapshot, begins terminating queries, and puts the cluster in a pausing state. If you delete a paused cluster without requesting a final snapshot, then you can't restore the cluster. You can't cancel or roll back a pause or resume operation efforts after it's initiated. So what you want to do is you want to make sure you don't delete a paused cluster because you'll lose that information. Okay? You can pause and resume a cluster on the new Amazon Redshift console, not the original console, with the AWS CLI or with the Amazon Redshift API operations. Okay, now let's look at renaming clusters. So with this, you can rename a cluster if you want the cluster to use a different name because the endpoint to your cluster includes a cluster name, also referred to as cluster identifier. The endpoint changes to use the new name after the rename finishes. For example, if you have a cluster named example cluster and rename it to new cluster, the endpoint changes to use new cluster identifier. Any applications that connect to the cluster may be updated with the new endpoint. Okay. Then let's look at shutting down and deleting. Okay. So you can shut down your cluster if you want to stop it from running and incurring charges. When you shut it down, you can optionally create a final snapshot. If you create a final snapshot, Amazon Redshift will create a manual snapshot of your cluster before shutting it down. You can later restore the snapshot if you want to resume running the cluster and querying data. Regardless of whether you shut your cluster down with the final manual snapshot, all automated snapshots associated with the cluster will be deleted after the cluster is shut down. Any manual snapshots associated with the cluster are retained. Any manual snapshots that are retained, including the optional final snapshot, are charged at the Amazon Simple Storage Service storage rate. If you have no other clusters running when you shut down the cluster, or if it exceeds the available free storage that is provided for your running Amazon Redshift clusters. For more information about snapshot storage charges, see the Amazon Redshift pricing page. Okay, so that is an overview of the clusters, or managing clusters overview. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about usage limits. So you can define limits to monitor and control your usage and associated cost of some Amazon Redshift features. So you can create daily, weekly, and monthly usage limits and define actions that Amazon Redshift automatically takes if those limits are reached. Actions include such things as logging an event to a system table to record usage exceeding your defined limits. Other possible actions including raising alerts with Amazon SNS and Amazon CloudWatch to notify an administrator and disabling further usage to control costs. So the idea behind this with managing limits is to keep your costs down. So whatever you're using Amazon Redshift for data-wise, you can scale it back and down when needed on a daily, weekly, monthly usage basis. Okay, and you can set limits to it so that it doesn't nickel and dime you off a bridge, basically. Financially, I'm talking about. You can define usage limits for each cluster. After your cluster is created, you can define usage limits for the following features: Amazon Redshift Spectrum and Amazon Redshift concurrency scaling. So usage limits are available with a release version 1.0.14677 or later in the AWS regions where Amazon Redshift Spectrum and Amazon Redshift concurrency scaling are available. A Redshift Spectrum limit specifies the threshold of total amount of data scanned in 1 terabyte increments. A concurrency scaling limit specifies the threshold of the total amount of time used by the concurrency scaling in 1 minute increments. A limit can be specified for daily, weekly, or monthly period using the UTC to determine the start and end of the period. Okay. If you create a limit in the middle of a period, when the limit is measured from the point to the end of the period, for example, if you create a monthly limit on March 15th, then the first monthly period is measured from March 15th through March 31st. So it just goes by the month. So right now it's September 17th. So if we were to set up a limit period or create a limit in the middle of a period, which we're basically in the middle of September, well, a few days over, but it's September 17th, so it would go till the end of the month. Okay. You can define multiple usage limits for each feature. Each limit can have a different action. Possible actions include the following: log to system table. So this is the default action. Information is logged to the STL usage control table. Logging is helpful when evaluating past usage and in deciding on future usage limits. For more information about what is logged, see the STL usage control in the Amazon Redshift database developer guide. Okay. Alert: Amazon Redshift emits CloudWatch metrics for available and consumed usage. You can define up to 3 usage limits for each feature. If you enable the alert action using the Amazon Redshift console, a CloudWatch alarm is automatically created on these metrics. You can optionally attach an Amazon SNS subscription to that alert. If you're using an AWS CLI or API operation, make sure that you create the CloudWatch alarm manually. When the threshold is reached, events are also logged to a system table. Disable the feature. When the threshold is reached, Amazon Redshift disables the feature until the quota is refreshed for the next time period, daily, weekly, or monthly. Only one limit for each feature can have the disabled action. Events are also logged to a system table and alerts can be emitted. So basically what they're saying is when you set the usage rate, and let's say that the usage limit, I should say, is set for a month. And let's say that you set it to 500 gigs, for example. Let's say that you're using storage with Amazon Redshift and your limit is 500 gigs. As soon as you get to 500 gigs, it's going to disable your ability to go over that so that you don't get charged above and beyond whatever the usage rate is above that, okay? And that's a good feature to have because it can get real expensive real fast if you're not setting limits on what you're doing. Now, if you don't have limits in terms of your budget, then don't use these features. Set it higher than that. A good rule of thumb is double your data size, and then that way you will never reach it. Okay? Usage limits persist until the usage limit definition itself or cluster is deleted. You can define and manage usage limits with the new Amazon Redshift console, the AWS CLI, or Amazon Redshift API operations. To define a limit on the Amazon Redshift console, navigate to your cluster and choose Configure Usage Limit for Actions. Okay? To view previously defined usage limits for your cluster, I'm having a tongue twister here. Choose the Maintenance and Monitoring tab Usage Limit section. To view the amount of usage available and consumed for your cluster, navigate to your cluster. Choose the Cluster Performance tab, then view the graphs for usage consumed feature. Okay? So there you go. So you can use the following Amazon Redshift CLI operations to manage limits. For more information, see the AWS CLI command reference. Now, we're going to go more depth into this, but let's just go over a quick overview of it, and then we'll talk about it in the upcoming videos. So create usage limit, describe usage limits, modify usage limits, and delete usage limits. Okay. Then you can use the following Amazon Redshift API operations to manage usage limits. So create usage limits, describe usage limits, modify usage limits, and then delete usage limits. Okay, so that is managing usage limits in Amazon Redshift. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about managing clusters using the console. So to create, modify, resize, delete, reboot, and backup clusters, use the cluster section in the Amazon Redshift console. Note, a new console is available for Amazon Redshift. Choose either the new console or the original console instructions based on the console that you are using. The new console instructions are open by default. Okay, so to get to the new console, which we're not going to go any further than these 3 steps right here, is sign into the AWS Management Console and open the Amazon Redshift console at this link. On the navigation menu, choose clusters. The clusters for your account and the current AWS region are listed. A subset of properties of each cluster is displayed in the columns in the list. If you don't have any clusters, choose Create Clusters to create one. Choose the cluster name in the list to view more details about a cluster. Okay, so let's close that down. And then let's look at the original console. So when you don't have any clusters in AWS region, you open the clusters page. You have the option to launch a cluster in the following screenshot. The AWS region is the US East North Virginia region, and there are no clusters for this account. Okay, so you can see here, you can do $1,000 per terabyte per year, that's pretty good. Okay, so when you have at least one cluster in an AWS region, the cluster section displays a subset of information about all the clusters for the account in the AWS region. In the following screenshot, there is one cluster created for this account in the selected AWS region. You can expand a cluster to view more information about the cluster, such as the endpoint details, cluster and database properties, tags, and so on in the following screenshot. Okay, so example cluster is expanded to show a summary of information about the cluster. So this is what you would have if you created a cluster. It would show you all the information here and all the properties, the backup, the audit, the maintenance, cluster status, and then the cluster properties. Okay. So on this page, they talk about the following: creating a cluster, modifying a cluster, deleting a cluster, rebooting a cluster, resizing a cluster, upgrading the release version of a cluster, getting information about cluster configuration, getting an overview of cluster status, creating a snapshot, creating or editing disk space alarm, and then working with cluster performance. So let's look at creating a cluster first. Now you'll notice they have original console and they have new console. Okay, so I am going to go over both because I think it's important to understand that some people will want to use a new console and some will want to use the old console, or the original, I should say. One way to learn, again, this is just going to kind of, to create a console, we would sign in on the navigation menu, choose clusters, create clusters, and then follow the instructions on the console page to enter the properties for the cluster configuration. Then we're going to follow the instructions on the console page to enter the properties of the cluster details, and then additional configurations. So we have virtual private cloud, parameter groups, encryption, KMS, HSM, and then maintenance track, monitoring, and configure cross-region snapshot. Now the original console, okay, create a cluster by using quick launch cluster, okay. So it's the same idea, but they have better documentation for this because this is a more developed console, right? So you can see here on the clusters page, choose the cluster that you launched and review the cluster status information, okay? So you can see your cluster status here based on this image. Creating a cluster by using a launch cluster, okay? So you would sign in, choose the launch cluster on the cluster details page, specify values for the following options, and then choose continue. Database name, database port, master username, and master user password, and confirm password, right? So that's where you put all this information right here. On the node configuration page, specify values for the following options and choose continue node type. So cluster type, and you can see here, node type, CPU, memory, storage, so we have 160 gig SSD storage per node, I/O performance, moderate, cluster type, number of computer nodes, maximum, minimum, okay. On the additional configuration page, okay, specify values for the following options, then choose continue. Okay, so again, and then you have configure network in options. So choose a VPC, cluster subnet group, publicly accessible, choose a public IP address, and then availability zone, right? And then you would continue on here to launch a cluster outside of VPC, choose not in VPC, okay? Cluster subnet group, publicly accessible, choose a public IP address, elastic IP, availability zone, enhanced VPC routing, okay, and then VPC security groups, cluster security groups, and then here you can see optionally create a basic alarm for this cluster, okay. So there you go. Now I'm going to scroll all the way down to the bottom here to this area here where we're finally at the end of the line here, and it gives you the cluster properties, database configuration, security access encryption, CloudWatch alarms. Now, don't worry about this because we're going to go in depth in a later video on all this, okay? So after you initiate the creation process, choose close. The cluster might take several minutes to be ready to use, okay? And then modify a cluster. So when you modify a cluster, changes to the following options are applied immediately. VPC security groups, publicly accessible, master user password, Hsm connection, Hsm client certificate, maintenance settings, snapshot preferences, etc. Okay. Okay, so we'll close that down. Okay, deleting deleting a cluster. If you no longer need a cluster, you can delete it. If you plan to provision a new cluster with the same data and configuration as the one you are deleting, you need a manual snapshot. So a snapshot is basically you're copying the data. Okay, they just call it a snapshot. The cluster data is deleted. In either case, automated snapshots are deleted after the cluster is deleted, but any manual snapshots are retained until you delete them. You might be charged Amazon Simple Storage Service rates for manual snapshots depending on the amount of storage you have available for Amazon Redshift snapshots for your clusters. For more information, see shutting down and deleting clusters. Okay, so rebooting a cluster. If we look at so you can see here to reboot a cluster in the new console, we're going to sign in. On the navigations menu, choose clusters, choose the cluster to reboot. For actions, choose reboot cluster, and the reboot cluster page appears. Choose reboot cluster, and you're good to go. Okay. Resizing a cluster. So when you resize a cluster, you specify a number of nodes or node type that is different from the current configuration of the cluster. While the cluster is in the process of resizing, you cannot run any write or read-write queries on the cluster. You can run only read queries. For more information about resizing, including walking through the process of resizing clusters using different approaches, see resizing clusters in Amazon Redshift. Okay, so if we look at the new console options, we're just going to do the same thing. Sign in. On the navigation menu, choose clusters, choose the cluster to resize. For actions, choose resize, and then the resize cluster page appears. Follow the instructions on the page. You can resize the cluster now, once at a specific time, or increase and decrease the size of your cluster on a schedule. Depending on your choices, choose resize now or schedule resize. Okay. Upgrading the release version of a cluster. So for the new console, you can just log in, choose clusters, choose the cluster to upgrade. Again, it's an action item. So for actions, choose upgrade cluster version. The upgrade cluster version page appears. Follow the instructions and then choose upgrade cluster version. Okay, pretty straightforward. Getting information about cluster configuration. Okay, so on the navigation menu, choose clusters and choose cluster names from the list to open its details. The detail of the cluster are displayed, including query monitoring, cluster performance, maintenance and monitoring, backup properties, and schedule tabs. Choose each tab to view more details. Okay. Then we have getting an overview of cluster status. So we would choose clusters in the navigation menu and then view the status of the cluster in the status column. Okay. Creating a snapshot. On the navigation menu, choose clusters and then choose the cluster which to create a snapshot. For actions, choose create snapshot. The create snapshot page appears. Follow the instructions on the page and then choose the create snapshot. Okay. Now, create or editing disk alarm is the same thing. You go to the navigation menu, choose alarms. For actions, choose create alarm. Create the alarm page that appears. Follow the instructions on the page and then choose create alarm. Okay. And then working with cluster performance data. In the new console, you can work with the cluster performance on the cluster performance tab of the cluster details page. In the original console, you can work with the cluster performance data using the performance queries and loads tabs. For more information about working with the cluster performance, see working with performance data in Amazon Redshift console. Okay, so that is managing clusters using the console. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about managing clusters using the Amazon Redshift CLI and API. Okay, so you can use the following Amazon Redshift operations to manage clusters. Okay, so cancel, resize, create cluster, delete cluster, describe clusters, describe cluster versions, describe node configuration options, describe orderable cluster options, describe resize, modify cluster, pause cluster, reboot cluster, resize cluster, and resume cluster. Okay. You can use the following Amazon Redshift API operations to manage clusters. So cancel, resize, create cluster, delete cluster, describe clusters, describe cluster versions, describe node configuration options, describe resize, describe orderable cluster options, modify cluster, pause cluster, reboot cluster, resize cluster, and resume cluster. Okay, so that's how you manage clusters using the Amazon and Sql and API. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about managing clusters using the AWS SDK for Java. So the following Java code example demonstrates common cluster management operations, including creating a cluster, listing metadata about a cluster, modifying configuration options. After you initiate the request for the cluster to be created, you must wait until the cluster is in the available state before you can modify it. The example uses a loop to periodically check the status of the cluster using the describe clusters method. When the cluster is available, the preferred maintenance window for the cluster is changed. Okay. So for step-by-step instructions to run the following example, see running Java examples. For Redshift using Eclipse, you need to update the code and specify cluster identifier. Okay, so this is just an example that they're using. So again, we'll get more into this later on, but I just wanted to show you exactly what they're talking about when they're saying managing clusters using the AWS SDK for Java. All right, so thanks for watching. I'll see you in the next video. All right, welcome to section 4, where we're going to talk about querying a database. So in this video, we're going to go over an overview of what we're going to learn throughout the section and also talk about what is querying a database. Okay, so first let's talk about that. To query a database hosted by Amazon Redshift cluster, you have two options. Connect your cluster and run queries on the AWS Management Console with the Query Editor. If you use Query Editor on the Amazon Redshift console, you don't have to download and set up an SQL Client application. Connect to your cluster through a SQL Client tool, such as Sql Workbench/J. Amazon Redshift supports Sql Client Tools connecting through Java Database Connectivity, Jdbc, and Open Database Connectivity, Odbc. Amazon Redshift doesn't provide or install any Sql client tools or libraries, so you must install them on your client computer or Amazon EC2 instance to use them. You can use most Sql client tools that support Jdbc or Odbc drivers. Okay, so that's what querying a database is. Now, in this section, we're going to talk about the query editor. We're going to talk about the SQL client tools, configuring connections in Amazon Redshift. Okay, then we're going to talk about security options, tools and code, and troubleshooting. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about querying a database using the query editor. Okay, so running the query editor is the easiest way to run queries on databases hosted by your Amazon Redshift cluster. After creating your cluster, you can immediately run queries by using the query editor on the Amazon Redshift console. The following cluster node types support the query editor. So DC1.8xlarge, DC2.large, DC2.8xlarge, DS2.8xlarge, RA3.4xlarge, and RA3.16xlarge. Using the query editor, you can do the following. Run single SQL statement queries, download result sets as large as 100 megabytes to a comma-separated value, CSV file, save queries for reuse. You can't save queries in the Europe-Paris region, the Asia-Pacific Asca region, and the Asia-Pacific Hong Kong region, or Middle East Bahrain region. View query execution details for user-defined details. Query editor considerations. Be aware of the following considerations. Okay, when you use the query editor on Amazon Redshift console, up to 50 users can connect to a cluster with the query editor at the same time. The maximum number of users connecting to a cluster includes those connecting through the query editor. Up to 50 workload management query slots can be active at the same time. For more information about query slots, see implementing workload management. The query editor only runs short queries that can complete within 10 minutes. Query results sets are paginated with 100 rows per page. You can't use a query editor with enhanced VPC routing. You can't use transactions in the query editor, and you can save a query up to 3,000 characters long. Enabling access to the query editor. To access the query editor, you need permission. To enable the access, attach AWS managed policies, Amazon Redshift query editor, and Amazon Redshift read-only access for AWS identity and access management permission to the IAM user that you use to access your cluster. If you've already created an IAM user to access Amazon Redshift, you can attach the Amazon Redshift query editor and Amazon Redshift read-only access policies to that user. If you haven't created an IAM user yet, create one and attach the policies to the IAM user. Okay, to attach the required IAM policies for a query editor, sign in, choose users, choose the users that needs access to the query editor, add permissions, attach existing policy directly. For policy names, choose Amazon Redshift query editor and Amazon Redshift read-only access. Choose next and then review, and then choose add permissions. Using the query editor, in the following example, you use the query editor to perform the following tasks: run SQL commands, view query execution details, save a query, and then download a query result set. With the new console, it's the same thing. We sign in on the navigation menu, choose editor, then connect to a database in your cluster. For schema, choose public to create a new table based on the schema. Enter the following in the query editor window and choose run to create a new table. So you'd enter this in here and then choose clear, enter the following command in the query editor window and choose run to add rows to the table. So right here, okay, and then choose clear, write the following command in the query editor window and choose run to query the new table. So select from shoes. Okay, so we're going to select the shoes table, right? And then the query result displays the results. So we have shoe type, color. So we have sandals, black, loafers, brown. Choose execution to view the run details and choose data, then export to download the query results as a file. Okay, so that is the query editor. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about Sql Client Tools. So you can connect to Amazon Redshift clusters for Sql Client Tools over Java Database Connectivity, Jdbc, and Open Database Connectivity, Odbc connections. Amazon Redshift doesn't provide install any Sql Client Tools or libraries. To use these tools or libraries to work with data in your cluster, install them on your client computer or Amazon EC2 instance. You can use Sql Client Tools that support Jdbc or Odbc drivers. You can use the following sections to walk through the process of configuring your client computer or Amazon EC2 instance to use the Jdbc or Odbc connection. They also discuss related security options for client connection to the server. Additionally, following you can find the information about setting up and connecting to example third-party Sql Client Tools, SQL Workbench, J, and pSQL. You can try these tools if you don't have a business intelligent tool to use yet. You can also use this section to learn about connecting your cluster programmatically. Finally, if you encounter issues when attempting to connect to your cluster, you can review the troubleshooting information in this section to identify possible solutions. So, topics. And these are the tools that we're going to be talking about in the upcoming videos. So configuring connections in Amazon Redshift, configuring security options for connections, connecting to clusters from client tools and code, and troubleshooting connection issues in Amazon Redshift. Okay, so those are the Sql Client Tools. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about configuring connections in Amazon Redshift. So in the following section, you can find how to configure Jdbc and Odbc connections to connect to your cluster from Sql Client Tools. This section describes how to set up Jdbc and Odbc connection. It also describes how to use secure socket layer, SSL, and server certificates to encrypt communication between the client and server. Okay, so Jdbc and Odbc drivers for Amazon Redshift. To work with data in your cluster, you need Jdbc or Odbc drivers for connectivity from a client computer or instance. Code your applications to use Jdbc or Odbc data access API operations and use Sql Client Tools that support either Jdbc or Odbc. Okay. Amazon offers Jdbc and Odbc drivers for download. Previously, Amazon Redshift recommended Postgres SQL drivers for Jdbc and Odbc. If you currently use those drivers, we recommend moving to the new Amazon Redshift specific drivers. For more information on how to download the Jdbc and Odbc drivers and configure connections to your cluster, see Configuring Jdbc Connection and Configuring Odbc Connection. Okay. Finding your cluster connection string. To connect to your cluster with Sql Client Tool, you need the cluster connection string. You can find the cluster connection string in the Amazon Redshift console on a cluster's detail page. So for the new console, to find a connection string for the cluster, we sign in on the navigation menu, choose clusters, then choose cluster name from the list to open its details. Okay. Choose properties tab for the cluster, then view connection details. Choose view all connection details to see the Jdbc URL and Odbc URL values. The connection string is based on the AWS region where the cluster runs. Choose copy to copy the connection strings needed for your driver. Okay. Now, if we look at configuring a Jdbc connection, okay, you can download an Amazon Redshift Jdbc driver, okay, and really that's all you need to do for Jdbc to get it to connect is just get the right driver. So download an Amazon Redshift driver, attain the Jdbc URL, configure the authentication SSL for Jdbc connection, configure TCP, keep alive for Jdbc connection, configure logging for Jdbc connection, configure Jdbc connection with Apache Maven, configure Jdbc driver options, and use previous Jdbc drivers in certain cases. Okay, so that's how you get Jdbc. I'm saying that a lot, but that's how you get it to work with Amazon. Okay, now we're going to talk about configuring the Odbc connection and what you need to do to get that working. So you obtain the Odbc URL for your cluster, install and configure the Amazon Redshift Odbc driver on Microsoft Windows if you're running Windows, install Amazon Redshift Odbc driver on Linux if you're running Linux, install the Amazon Redshift Odbc driver on Mac OS if you're running Mac, and configure the Odbc driver on Linux and Mac OS operating system. So this is how you configure it, and then configure Odbc driver options and use previous Odbc driver versions in certain cases. Okay, so that's how you configure an Odbc connection. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about configuring security options for connections. So Amazon Redshift supports secure socket layers, SSL connections, to encrypt data and server certificates to validate the server certificate that the client connects to. So connect using SSL. To support SSL connections, Amazon Redshift creates and installs AWS Certificate Manager, issued SSL certificates on each cluster. You can find the set of certificate authorities that you must trust to properly support SSL at right here. If the certificate bundle doesn't download, choose the previous link and save link as. By default, cluster database accept a connection whether it uses SSL or not. To configure your cluster to require an SSL connection, set the require SSL parameter to true and the parameter group that is associated with the cluster. Amazon Redshift supports an SSL mode that is compliant with Federal Information Processing Standard, FIPS 140-2. FIPS compliant SSL mode is disabled by default. Okay. To enable FIPS compliant SSL mode, set both use FIPS SSL parameter and then the require underscore SSL parameter to true and the parameter group that is associated with the cluster. Okay. Using SSL and trust CA certificates in Odbc. If you connect using the latest Amazon Redshift Odbc driver version 1.3.7.1000 or later, you can skip this section. To download the latest drivers, see here. You might need to update your current trust root CA California or CA certificates to continue to connect to your cluster using SSL. Okay. Now, if you get the updated driver, then you don't need to do any of this. Okay. So just what I recommend doing is updating your driver. And when we do this, we're going to get the latest driver. So we won't need to go through all this. There's a lot of information to digest here, and the less that you need to like go over that has no relative base for what we're doing, there's no reason to really talk about it. You know what I mean? So connect using the server certificate with Odbc on Microsoft Windows. If you want to connect to your cluster using SSL and the server certificate, first download the certificate to your client computer or Amazon EC2 instance, then configure the Odbc DSN. Okay. Download the Amazon Redshift Certificate Authority Bundle to your client computer at the lib folder in your driver installation directory and save the file as root.crt. Open Odbc Data Source Administrator and add or edit the system DSN entry for your Odbc connection. For SSL mode, select Verify Full unless you use DNS alias. If you use DNS alias, select Verify-CA, then choose Save. Okay. Now, using SSL and Server Certificates in Java. SSL provides one layer of security by encrypting data that moves between your client and a cluster. Using a server certificate provides an extra layer of security by validating the cluster is an Amazon Redshift cluster. It does so by checking the server certificate that is automatically installed on all clusters that you provision. For more information on using server certificates with Jdbc, go to Configure the Client in the post GRE SQL documentation. Okay. So the one thing I'm going to say about SSL certificates is no matter what you're doing, whether it's on Amazon, Redshift, or on your own hosting, you always want to have an SSL certificate, because what that's going to do is it's going to encrypt your data and keep it safe from attacks and from people trying to infiltrate your data. Okay. Connect using Trust CA certificates in Java. Okay. If you connect using the latest Amazon Redshift Jdbc driver version 1.2.8.1005 or later, you can skip this section. To download the latest drivers, see configure a Jdbc connection. Okay, so if you have this driver, which we're going to do later, you don't need to carry on with this. Okay, so we're going to end it there. This is configuring security options for connections. Thanks for watching, and I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about connecting clusters from client tools and code. All right, so this section provides some options for third-party tools to connect to the cluster if you do not already have a business intelligence tool to do so. Additionally, it describes how to connect your cluster programmatically. So let's look at how to connect to your cluster by using Sql Workbench J. Okay, so Amazon Redshift doesn't provide or install any Sql client tools or libraries, so you must install any that you want to use with your cluster. Okay, so install Sql Workbench /J, review Sql Workbench software license. If you click there, go to the Sql Workbench website and download the appropriate package for the operating system on your client computer or Amazon EC2 instance. Okay, and then go to install and starting Sql Workbench page, follow the instructions for installing the Sql Workbench on your system. Okay. Connect to your cluster over Jdbc connection and Sql Workbench J. You open Sql Workbench J, choose File, then choose Connect Window. Choose Create a New Connection Profile. In the New Profile box, type a name for the profile, for example cluster _ Jdbc. Choose Manage Drivers. The Manage Drivers dialog opens. In the name box, type a name for the driver. Choose the folder icon next to the library box. Navigate to the location of the driver. Choose it, then choose open. Sorry. In the driver box, select the driver you just added, and URL copy Jdbc URL from Amazon Redshift console and paste it in here. Paste it here. In the username, type the username of the master user. in password, type the password associated with the master user account. Select Auto Commit box. Choose the Save Profile List icon as shown below. Okay. Choose OK, and then test the SQL Workbench connection. So you can use the following query to test your connection. Select from information underscore schema.tables. If your connection is successful, a list of records appears in the Results tab. Okay. So you can see it here. Alternatively, if you loaded the sample tables and the data from Amazon Redshift getting started, you can test your connection by typing the following query into the statement window. Select from users order by user ID, limit 100. If your connection is successful, a list of records appears in the Results tab. Okay, so to show this, so that's how you get started with the how to connect your cluster by using SQL Workbench/J. Now let's talk about connect your cluster by using pSQL tool. Okay, so connect by using the pSQL defaults. To connect, you sign in, choose the following steps depending on which Amazon Redshift console you're using. The new console and navigation, choose clusters, then choose the cluster name from the list that opens the detail. On the Properties tab in the Database Configuration section, record the database name and port. View the connection details section and record the endpoint, which is in the following form: endpoint:/port/database name. Okay. The original console has a different option, but we're going to go with the new console because it's more user-friendly. At command prompt, specify the connection information by using either command line parameters or connection information string. To use parameters, do pSQL-h endpoint-u username -d for database name and then -p for port. Where endpoint is the endpoint you recorded in the previous step. User ID. User ID is a user ID with permission to connect to the cluster. Database name is the database name you recorded in the previous step, and port is the port you recorded in the previous step. Okay. At the pSQL password prompt, enter the password for user ID user. You are connected to the cluster and can interactively enter commands. Okay. Connect by using a certificate. Okay. To connect by using a certificate, save the download Redshift certificate authority bundle .crt file to your computer, and then choose one of the following steps depending on which Amazon Redshift console you're using. So we're going to use the new one again. In the navigation panel, choose clusters, then choose the cluster name from the list to open its details on the Properties tab in the Database Configuration section. Okay. Now let's talk about connect your cluster programmatically. Okay. So we can connect to a cluster by using Java. Okay. When you use Java to programmatically connect to your cluster, you can do so without server authentication. If you plan to use server authentication, follow the instructions here to put the Amazon Redshift server certificate into a key store. You can refer to the key store by specifying a property when you run your code as follows. Okay. All right, so this is an example of the code you would run for step-by-step instructions to run the following example. See running Java examples for Redshift using Eclipse. Okay, so now let's talk about connecting to a cluster by using .NET. Okay, so for this, when you use .NET, C# to programmatically connect to your cluster, you can do so with or without server authentication. Same as Java, okay? Example, connect to a cluster by using .NET, and then you can go here to see the example and get a breakdown of that. Okay, so that is tools and code. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about troubleshooting. So troubleshooting connections issues in Amazon Redshift. So if you have issues with connecting to your cluster from a SQL Client Tool, there are several things you can check to narrow down the problem. If you're using Ssl or Server Certificates, first remove this complexity while you troubleshoot the connection issue. Then add this back when you found a solution. Okay. So for more information, see configuring security options for connections. Okay. So when you go here for troubleshooting connections connection issues in Amazon Redshift. They have multiple topics that you can go to. So connecting from outside of Amazon EC2 firewall timeout issue, connection is refused or fails, client and driver are incompatible, and queries appear to hang and sometimes fail to reach the cluster. So these are all options that they cover in this section if you're having issues connecting to Amazon Redshift. Okay, so we're not going to go in real detail on that because we don't have an account set up yet to even test anything, and so there's really no reason to do that. Okay, so that's how you would troubleshoot connection issues in Amazon Redshift. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about using the Amazon Redshift Data API. Okay, so you can access your Amazon Redshift database using the built-in Amazon Redshift Data API. Using this API, you can access Amazon Redshift data with web services-based applications, including AWS AWS AppSync, Amazon SageMaker notebooks, and AWS Cloud 9. For more information on these applications, see the documentation here. Okay. The Data API doesn't require persistent connection to the cluster. Instead, it provides a secure HTTP endpoint and integration with AWS SDKs. Okay. Working with the Amazon Redshift Data API. Before you use the Amazon Redshift Data API, review the following steps. Determine if you, as the caller of the Data API, are authorized. Determine if you plan to call the Data API with authentication credentials from Secrets Manager or temporary credentials. Set up a secret if you use Secrets Manager for authentication credentials. Review the considerations and limitations when calling the Data API. Call the Data API from the AWS command line interface, AWS CLI, from your own code or using the query editor in the Amazon Redshift console. Authorizing access to the Amazon Redshift Data API. To access the Data API, a user must be authorized. You can authorize a user to access the Data API by adding a managed policy, which is predefined AWS Identity and Access Management, so IAM policy, to that user to see the permissions allowed and denied by managed policies. Okay. Storing database credentials in AWS Secrets Manager. When you install the Data API, you can pass credentials for the cluster by using a secret in AWS Secrets Manager. Okay. To pass credentials in this way, you specify the name of the secret or Amazon resource name, ARN, of the secret. To store your credentials in a secret for Amazon Redshift cluster, use the AWS Secrets Manager to create a secret that contains credentials for your cluster. When you choose Store a new secret, choose credentials for Redshift cluster, store your values for username, database user, password, database cluster, identifier in your secret. Okay. And then use the AWS Secrets Manager console to view the details for the secret you created, or run the AWS Secrets Manager describe secret AWS CLI command, note the name and ARN of the secret. You can use these in calls to the Data API. Okay. Considerations when calling the Amazon Redshift Data API. Consider the following when calling the API. The maximum duration of a query is 24 hours. The maximum query result size is 100 megabytes. If a call returns more than 100 megabytes of response data, the call is ended. The maximum retention time for query results is 24 hours. The maximum query statement size is 100 kilobytes. The Data API is available to query single node and multiple node clusters of the following node types. So DC2.large, DC2.8x large, DS2x large, and DS2.8x large, and then RA3.4x large and RA3.16x large. The cluster must be in virtual private cloud based on the Amazon VPC service. Okay. Choosing the authentication credentials when calling the Amazon Redshift Data API. Okay. So Aws Secrets Manager. With this method, provide the secret value that is stored in Aws Secrets Manager. The specified secret contains credentials to connect to your database. You also supply a value for cluster identifier that matches the cluster identifier in the secret. Temporary credentials. With this method, provide your cluster identifier, database, and database user values. With either method, you can also supply a region value that specifies the AWS region where your cluster is located. Okay. Mapping Jdbc data types when calling the Amazon Redshift Data API. The following table maps Java database connectivity, Jdbc data types to the data types you specify in data API calls. Okay. For some specific types, such as decimal or time, a hint might be required. The hint instructs the data API that the string should be passed to the database as a different type. You can do this by including values in type hint in SQL parameter data type. The possible values for the type hint are the following. Decimal, the corresponding string parameter value is set as an object of decimal types type to the database. Timestamp, the corresponding string parameter value is sent by an object of timestamp type to the database. The accepted format is year, month, and date, hour, minute, second, and frames. Time, the corresponding string parameter is an object of time type to the database. The accepted format is hour, minute, second, and then the date is the corresponding string parameter value set as an object of data type to the database. The accepted format is year, month, and date. Okay. Troubleshooting the data API issues. Topics, packet for queries too large, database response exceeds size limit. So if the packet for query is too large, if you see an error indicating that the packet for a query is too large, generally the result is set return for a row is too large. The data API size limit is 64 kilobytes per row, and the result set return by the database. To solve this issue, make sure that each row in a result set is 64 kilobytes or less. So don't go over 64 kilobytes per row. Okay. Database response exceeds size limit. If you see an error indicating that the database response has exceeded the size limit, generally the size of the result set returned by the database was too large. The data API limit is 100 megabytes, and the result is set returned by the database. To solve this issue, make sure the calls to the data API return 100 megabytes of data or less. If you need to return more than 100 megabytes, you can run multiple statement calls with the limit clause in your query. All right, so that is the Amazon Data API. Thanks for watching. I'll see you in the next video. Congratulations on finishing Amazon Redshift. In this video, we're going to go over a summary of what we learned throughout the course. So in section 2, we talked about Amazon Redshift, what is Amazon Redshift, and management overview. In section 3, we talked about managing clusters, so usage limits, console, CLI and API, AWS, SDK for Java. Section 4, we talked about querying a database, so query editor, Sql Client Tools, configuring connections in Amazon Redshift, security options, tools and code, troubleshooting, and data API. So again, thanks again for watching Amazon Redshift. If you have any questions about the course or anything related to the course, please let me know. I'll be happy to help you in any way that I can. Until next time, thanks for watching and take care.